Okay, in Algebra 2 we have a quiz tomorrow on Chapter 1. And this is not too lengthy, but it'll probably take the entire 47 minutes that we have in class. And so if you want to prepare yourself for the quiz, it's everything in Chapter 1 that we've covered. I'll show you some of the points of emphasis. The first thing you should know is your number systems. That's the chart I showed you at the beginning of the year, where we talk about the real numbers, rational numbers, irrationals, etc. So understand that. And know how to evaluate. I'll give you a quick example of that. Here's an evaluate problem. Let's say we have, 3x cubed plus 4x plus 1, and we say evaluate for x equals -2, and that would all be given to you. And our goal is to just figure out what this expression is equal to when x is -2. So we do substitution. If there's an x, we replace it with a -2, and then we solve that. Well, -2 cubed is -8, so we get -24 minus 8, oops, I should say plus 1, plus 1. That's -32 plus 1, or -31. So we've evaluated it and came up with that answer. Number 3, know how to simplify expressions. And essentially you're applying order of operations and combining like terms until you get to an expression that you can no longer combine like terms to. So for example, it might be something like this equation, and we distribute our 3. We look for like terms. Here we have x terms that are alike. And our constants, 6 and -6, they just cancel out, and so can't do anything more to an 8x. Next basically is solving one variable inequalities and equations. So that would be 4. Solve one variable equations and equations, and they could have or inequalities, and this is with or without absolute values. So this is going to be the majority of the test. You can see just by the description of it. So I'll try and do one of each really quick, not all of them. We've seen plenty of examples in class, but this is what we mean to start out with. Just a simple inequality. -6 is less than 2. And we have to solve that. So we'll add 6 to both sides, and we get x is less than 8/5, and you should be able to graph this thing. And so our graph, and I'll give you number lines. There's 0, there's 1, there's 2. 8/5 is 1 3/5. So 1.6, it's about right there. It should be an open circle, and we want things to the left of it. So it's pointing to the left to indicate all the numbers that make it true are down there. Okay. The only thing I would remind you of for all of these types of problems is if you have a negative in front of your x, like this one. Oops, let's not use equals, let's use an inequality, because that's where we can really see it happening. We'd subtract our 5, so it's just like a normal problem. But then right here, when we divide by -2, the big key is what happens to this inequality right here. Instead of being a greater than anymore, because we divided by a negative, we did the division by a negative, it flips that inequality, and we still just do the math like normal, but the inequality actually becomes a less than symbol. Okay, again, the graph of this thing won't be quite as elaborate. Here's -2, we'll show where -3 is at, and we've got to be less than it, so we're pointing to the left. Okay, Of course, we have our combined inequalities. 2x minus 4 is greater than 6, or 2x minus 12 is greater than 15. Okay, so this is a combined inequality, and we just solve both of those just like we did on the previous page, but then we have to interpret these results. So x is greater than 13.5. I'm going to go to a decimal there. You could have left it as 13.5 or 27/2. And by interpreting it, I mean, if you first just graph the solution, it looks like this. Here's everybody greater than 5. Here's everybody greater than 13.5. But this is an OR statement. To be true, see, we have to treat this entire equation, or this compound statement here, we treat that thing as one big entity. Okay? So this whole thing is true if either the left side is true, this side, or if this one is true, then the whole thing is considered true. So if we look at the graph, on the graph, what we're going to notice is that everybody to the right of 5 makes one of the statements above true. From 5 to 13.5, this one, the one on the left is true, and the one on the right is not. And after 13.5, they're both true. But because it's an OR statement, we only care if one of them is true. And so our simplest solution for this would just be any number greater than 5 makes at least one of our statements true. And we'd put that answer in set notation. We've practiced that in class. And so there's our solution set. And the last type of problem I'm going to do, as an example for your test tomorrow, looks like this. The absolute value of 2x plus 4 minus 3 equals 8. Okay, absolute value, let's make it an inequality, is greater than 8. We've worked a number of these today in class. Step 1, isolate that absolute value so you can think of it as a distance problem. Okay, so our distance is more than 11 units. Next, we break this into two statements. Well, if a distance is more than 11 units, then we have to be further than 11 units away, or we could be further away than 11 units by being less than negative 11. And see, now we've broken it down into two inequalities, and it's very similar to this last problem we did, okay, where we had two inequalities joined by an OR. This is a greater than symbol, and greaters mean OR for us when we're dealing with distances, because we're going away. They aren't going to overlap, these two graphs, when we get done. So let's just solve these. 2x is greater than 7, x is greater than 3.5, or we'll subtract 4, that's negative 15, so x is less than negative 7.5. So we are outside, if we look at the graph, we're less than negative 7.5 this way, but we're greater than 3.5 that way. Okay, if you want the solution set, it's all x values where x is less than negative 7.5 or x is greater than 3.5. Okay, so make sure you review some of the notes that we've taken in class, review these problems, some of the homework we've done, and I think you'll be in pretty good shape. You will have an answer sheet tomorrow to put all your answers on. You have your test you have room to work on, so do all your work on the test. And good luck.